Hey Mechanical Tools 1 learners, this is Mr. D and I'm in my lab, and this week we're going to be talking about micrometers. So if you haven't seen a micrometer, there's one right there in the background pointing to it, and there's also small micrometers. This one in particular can measure up to 25 millimeters. That is the measuring distance or the thickness or maybe the diameter of the part. So if you kind of eyeball the part and you say, hey, I think it's within that range of, in this case, 25 millimeters, then you're good. Okay. So with this device, and I'm not going to go over the parts because I got a nice handout sheet. It'll have the descriptions. It'll explain the functions. I'm just going to show you the basics of how it works. So right here, I have this little guy in the back that I'm rotating. And as you can see, the gap is increasing. So between the gap, that would be the part that you want to measure in terms of thickness or maybe the diameter of that part. And I can go in the opposite direction. And it's very precise because once you find that dimension you want, you can take this little lever, lock it in, and it won't move it for you. As a matter of fact, you can hear it ratcheting, right? So it's got a gearing system, and therefore it allows a nice, smooth, linear motion, but also it has a rotation motion. So it's kind of a rectilinear device for measuring, okay? Another cool thing about this micrometer, you can see here, it's got 0.01 millimeters. Well, that's pretty small in terms of its capabilities of measuring, say, diameters of parts or thicknesses of parts. So that's 100 of a millimeter that it can measure in terms of thicknesses or diameters. So that is pretty precise in terms of what you can measure with this little mini micrometer. The guy in the back here, here's my finger, that one can measure up to 10 thousandths of an inch. So again, depending on what your application, what you're measuring, you have these two different sizes of micrometers that will allow you to measure very precise measurements. Okay, so without further ado, I'm going to put down this micrometer here, the small one. This is the millimeter. And we're going to look at the English version of that guy right here. So what I have in front of the camera is another little test fixtures. And test fixtures are important in manufacturing because if you need to, say, gauge something like a part, or you need to take some specialized measurement, if you have those skills to do that, you can go ahead and do it. So I have this little demonstration here where I want to make sure that the micrometer is locked into place, and I know that in this case, the part that we're manufacturing, here's my favorite little automotive boat, it will assure me that the measurement is correct. So on this side right here, I have the what's called a multimeter. It's a digital multimeter. And what a multimeter allows you to do is you can measure voltage, current, and resistance. And manufacturers who make multimeters will add in other special functions, like you can do data logging, or you can measure temperature. Some will even actually measure the frequency, meaning the cycles per second of a signal. So this guy right here, we're not going to look at those special functions. We just want to look at one particular function, which is the continuity or ohm meter function. And what that function allows you to do is to check out resistance, meaning in this case, if we're talking about continuity, we want to make sure that there's no break in the wire. So we can use this guy to do that. And another little special note or I should say tidbit that's related to the ohm meter is when we do those measurements, we remove all the voltage out of the circuit because this ohm meter is putting out a little bit of current. And if you have, say, a voltage source that's tied to the device you want to measure, meaning resistance, that current will basically overpower your ohm meter and it will damage it. And depending on the amount of current, it can actually do some really significant damage, like, I'm talking about blow up, right? And that's not good because inside that guy is small little electronic parts, and those guys will act like little, projectiles, which is like shrapnel. And if you're in that vicinity, it could do some damage to you or to your coworker. So if you're going to play around with measurement instruments, in this case an ohm meter, remember, remove the voltage from that source that you're taking the resistance measurement. Okay, so this is how this fixture works. Basically what I have here is, again, I want to make sure that my micrometer is measuring the proper length, and I want to make sure that this part is gauged properly, meaning it's in these two measuring points right here, one, and there's another one right in there. Okay, so I have my part that I'm measuring, and I want to see what the length is. So the way it works is I have this little sense wire, and there's also one that's attached to the other side of this micrometer. So when I slide this sense wire over, okay, you're going to see the reading change. Okay, and right now I don't have it properly placed on the fixture, and there it is. Okay, so it's showing 0.6 ohms, and that's really, really small, which is showing that, hey, it's got a good continuity. So that's letting me know that my, in this case, fastener is properly adjusted to the micrometer, and I can, read it because there's a scale right here. I can get that reading off of there, and I can do that. It's repeatable, and that's what test fixtures are for. We can use it for quality assurance. Take a sample size, and it's a random sample size, and then we can go ahead and make sure that the part that we're manufacturing meets the requirements of the spec that the customer wants, and we have this little simple test fixture that will allow us to do that. Okay, something else about the ohm meter, and this is the last point of how this device works. Notice it has the reading. Well, it also has an audible feature, so there it is. And what that allows you to do is, instead of you looking at the screen, you can hear it with your ear. Now, it gives both capabilities. If you have hearing impaired or visual impaired, you have those two features that will help to compensate for the deficiency either from hearing or visual. Let me turn it off. That's pretty loud. Okay, so if I slide it back over, this is my sense wire. Okay, it will read that value, and the OL means it's open load. Okay, so there's no load attached to the ohm meter, and that's what you're seeing there. Okay, so my little demonstration, I'll probably add a brain to it like I did last week with the dial calibers, and show what the measurement is. And there's so many different things I can do with that. I can create a little data logger, and I'll be exploring that and actually publishing that on the website, because I do write for various technology or engineering magazines. One in particular is Design News. Okay, so that's a quick introduction to the micrometer, the lecture notes, reading assignments, the worksheets, everything you need to get engaged with this subject will be there online. And again, if you want to partake in the lab, there Wednesday from 5 to 7 o'clock. I have one learner that's there, and he seems to be enjoying it. And again, if you got any questions, you can come by. If you need more clarification, you can come by. So that's what that day is really for, is if you want to do some hands-on stuff, play around with cool little devices like, ooh, look at that camera, gotta get focused, there it is, with a micrometer or the calibers. If you want to mess around with some other tools, I have in our electromechanical lab, we have trainers, so you can practice using various tools. If you want to know more about like electrical instruments, it's there. Okay, so that's it, and hope you guys have a good week. Talk to you later. Bye.